The next exam objective is called Construct Pivot and Unpivot Statements to return desired results based on supply data. We will discuss pivoting and unpivoting, what it is and how to do it, and along the way we will pay particular attention to null values. A pivot statement does a combination of two things. First, it turns values from one column into separate columns. Second, it aggregates data, which is the reason why we discuss this pivot statement right after the grouping and windowing functions. And the unpivot statement does almost the exact opposite. This explanation probably is not that clear. You can look up the definition in Microsoft Docs, but that explanation is probably not that clear either. So we will start with a realistic example of a situation that would benefit from using a pivot statement, the actual pivot statement and its output. After that, we will give a better explanation of the pivot statement and its components based on this example and start building a pivot statement from scratch based on a single, simple table. Suppose your manager wants a list of the quantity of items sold for the top selling products for each of the top customers. With the knowledge from the previous chapters, you can retrieve this data from the Wide World Importers database. For the sake of convenience, let's limit ourselves to the top 5, define our top 5 customers as the ones with the most orders, disregarding order amount, and the top 5 products as the products that appear on most order lines, disregarding quantity. Your query would look something like this. And the result would look like this. Your manager is satisfied with the data, but not with the format of the output. Just run the same query for the top 100 and you can see why not. It is just not informative. What he wants is a grid report with customers in the columns and products in the rows. There are 3 ways you can achieve this without disappointing your manager. First, you can take Excel and start cutting and pasting. Second, you can rewrite this statement using a lot of case or join statements. This will do the trick, but the resulting code will not be legible. The third option is the topic of this exam objective. Use the pivot statement. This is the pivot statement to achieve this result. Using a table, or in this case a derived table as input, SQL will create a result set where a list of specified values from one column from the input will be turned into separate columns in the output, in this case the 5 listed names for the column customer name. A second column from the input will be used to calculate aggregate values for the new output columns, in this case the column quantity. The third column from the input will be used to group by, in our case the column stock item name. Or to be more precise, all remaining columns from the input will be used to group by. Usually you only want to group on one column, so if your table has more than the 3 required columns, use a derived table to return only those 3, eliminating the rest, just as we've done here. Don't worry about the details of the query yet. After watching this video, you should be able to review and understand this query. But when we execute this query, you will see that it returns the same numbers as the previous query, but in a different format. The goal for now is to make clear what a pivot statement is and what it is used for. Now, let's start building one from scratch to make clear how it works. For that, we'll create a simpler version of a sales table with just 3 people buying groceries. Once again, I will open a second query window so you can compare the results of the queries to the raw contents of the table. As a first example, we'll pivot by customer. To do this, we use the keyword pivot. In between parentheses, we use an aggregate function on one of the columns and list a subset of the values for another column after the keyword for. These values are also used in the select clause. These values will be turned into columns. Unfortunately, these values have to be hard-coded into the statement. There's no simple way of creating a statement that fetches these values from the table. There is a hard way, creating a statement using dynamic SQL. On the website you can find a sample script for this. Another thing worth mentioning, like a derived table, the pivot statement needs to have an alias. You can reference this alias in the select clause, but that is optional. As you can see, the pivot returns one column each for Bill, John and Diana. The column product is not used in the pivot statement, so the value for this column is turned into rows. And the third column is used in the aggregate function, so the resulting values of this function become the cells of our grid. Bill has bought neither apples nor bananas, so here null values are returned. You can just as easily pivot by product. Let's do that and see what happens when we include a product in the listing that none of these customers has bought. Magic mushrooms. Here we have to hard-code the names of the products in the pivot statement and the select clause. The values for customer become the rows, and once again we calculate the total quantity. As you can see, all values for total sales quantity for magic mushrooms are null. We've now demonstrated the use of all three columns, in this case customer, product and quantity. We mentioned earlier on that a pivot statement needs three columns. One from which a list of specified values will be turned into columns, one on which an aggregate function will be applied. The result of this function will become the values for the newly created columns, and that all remaining values will be used to group on. Usually there's only one remaining column. Let's add one and find out what happens. We will add a column, customer ID, and fill it with values. We will now execute the same query as before. Note that we do not reference this newly created column in the statement at all. With the extra column in the table, this is the result. As you can see, there are now 2 or 3 rows for each product. Effectively, we've now performed a group by product customer ID. This combination was probably not useful. We've now demonstrated that all remaining columns will be used to group on. That is why the pivot statement is often applied to a CTE with only 3 columns instead of to the underlying table. If you rerun the statement that pivots by product, you will effectively group by customer ID. And since there's a one-on-one relation between them, the 4th column doesn't make a difference in that case. Let's drop the column as we don't need it anymore and move on to unpivoting. Unpivoting is basically the reverse of pivoting. You take a list of columns and store the values in a single column. To demonstrate this, we'll create a table by selecting the results of the pivot statement into a new table. We will call that table Pivoted Sales Table. This will be the content of the Pivoted Sales Table. The unpivot statement looks pretty much the same as the pivot statement. Following the for keyword, you specify the name of the new column and which values from the table should be converted from columns to values in that column. There is no aggregate function applied as we are unpivoting. And also the alias is required even when it isn't used elsewhere in the query. And the result? As stated, the unpivot statement has no aggregate function. And there's no unaggregate function to completely reverse the effect of pivoting. In the original table, there were 2 records for John buying apples, and SQL has no way of knowing that from the pivoted sales table. Therefore, in the unpivoted pivot table, there's only 1 record for John buying apples. So unpivoting is not the exact opposite of pivoting. The second exam objective we need to cover for pivoting is called Determine the impact of null values in pivot and unpivot queries. It's important to be aware of the impact of null values in all statements. In the examples above, you can see the resulting null values. For example, Bill did not buy apples, therefore the sum quantity of his apple sales is null. In Module 1, we saw how to replace a null value using isNull or coalesce. Note that you can't do this directly in the pivot statement, but that you have to do this in the select statement. Also, different aggregation functions will produce different results. If we take our first pivot query on this table and use count instead of sum, no null values will be returned. I will leave it to you to test the effect of other aggregate functions on null values. Min, max, average, etc. You can enhance this example by adding a record to the sales table with a null value for quantity. But note that you cannot use two aggregate functions in the same pivot statement, so the following won't work. This is all you need to know about pivoting. Before we move on, let's drop these tables. So, to recap, we've demonstrated how the pivot statement turns values from a table into rows and columns. We've shown that you need to list the values that you want to turn into columns and how to apply an aggregate function that will supply the values for these columns. We've also shown that all data will be grouped on all the remaining columns and that you can use a CTE to circumvent this problem. Also, we've shown how unpivot does the reverse as pivot, well, almost the reverse. That's it for the section on grouping data. We've covered how to group data using grouping functions, windowing functions and pivoting. So now, on to the next section.